Strong versus weak acids and bases. Strong and weak acids are the key concept in chemistry. Strong acids completely dissociate in their ions in water, while weak acids incompletely dissociate. The same is true for strong bases and weak bases. Okay, but what does this mean? Let's say that we have a strong acid like hydrochloric acid, HCl. When it's put in water, the acid will dissociate. Great, what does that mean? If we take a closer look, we would find that the molecules are splitting up, or as we put it before, dissociating. In this example with the hydrochloric acid, if put in a solution, we would find that the acid would separate into H+ and Ci-. Written out, it would look like this. And note that the arrows only point one way because the ions of the strong acids do not recombine. Cool. What about the other end of the spectrum, weak acids? The main difference here is that they only partially dissociate. For example, we'll use something like acetic acid, although there are many weak acids out there. If we put this in a solution and look closely, we would find that only a few molecules would split up. Hence, the weak acid would only partially dissociate. This reaction written out would look like this. Now, with this one, there is a double arrow indicating that both the forward and reverse reactions occur at equilibrium. With this done, what about bases? They work with the same idea in mind. If we take a weak base, such as ammonia, which is NH4+, and put it into a solution of water, it would partially dissociate, so the molecules in the water would become the following. On the other side, a strong base like sodium works the same way as a strong acid in water by completely dissociating. So, in the end, it would separate into these molecules. However, unlike other reactions, this reaction will make the electrons rip apart the surrounding water molecules to release hydrogen gas and a lot of heat. And this reaction will happen very fast and will be violent. In fact, in 1947, during World War II, there was huge amounts of sodium used. Following the war, however, they needed to dispose of the strong base, which they did, resulting in an extremely large reaction. In the end, the reaction produced an estimated 162,000 cubic feet of hydrogen gas. With that all being said, weak and strong bases and acids have some interesting stuff behind them. Thank you.